Hello everyone, welcome to segment 3 of video series on payment card. In the last lectures, we have discussed about different type of cards available in the market. We have also discussed about how card number is generated and how it is verified by using the Lens algorithm. We have also discussed different vendor involved in from printing the card to delivering it to your home. We have also discussed about the role of different persons or entities in the payment card like issuer, acquirer, and other entities involved in the transaction. In this video, we will discuss about EMV card and how it is beneficial and what are the advantage of EMV cards over MaxTip card. So first we will look about the background of MaxTip card. In MaxTip card, data is stored in the magnetic strip on the back side of your card. The data is stored on two different tracks. We call it track 1 and track 2. In the MaxTip card, we stored card number, cardholder name, expiry date, service code, CVV1, and optionally some issuer also store PVV data in the magnetic strip. In the magnetic strip, data is repeated in both the track 1 and track 2. Uh, in this magnetic strip card, data format is not flexible. As you can see, the data are separated by caret symbol or equal sign. Hence, these are less interoperable. In the magstrip card, for both terminal and card has to agree on some format to make the card operational. In usual case, the data is separated by using caret symbols. Data storage in magnetic strip is minimal. We can store less than 16 kilobytes of data in the magnetic strip card. In the magnetic strip card, data cannot be updated once the card is issued to the customer. Another disadvantage of magnetic strip card is that uh, if the customer is having two products with the bank, suppose a customer is having one RuPay credit card and one RuPay debit card, then bank has to issue two different cards, one for each product in case of magnetic strip card. While in case of EMB, one card can serve the purpose of two different products. In magnetic strip card, we will discuss about how authentication happens. So, authentication is to ensure that card is valid and also to check the ownership of the card holder. So, first the uh, card is verified by merchant by using the looks of the card, like the name of the customer should be printed, name of the issuing bank should be printed on the card, and name of the payment scheme should also printed on the magnetic strip card. By looks at the size of the plastic or metal card issued to the customer, merchant verifies that card is genuine. Secondly, merchant has to verify the card holder. So card holder signature is verified by using the 4-digit PIN. So this is the background of magnetic strip card. Now let's discuss about the advantage of EMV cards. In EMV card, more data can be stored since the memory is more than 16 kilobyte and it allows multiple records to store in the EMV chip card. In EMV chip card, it is very flexible for file organization. Data is grouped into files, record, data elements, and stored in BERTLV format. EMV cards are designed to store multiple products. Here, the products here we in case of ICC or EMV, we refer product as application. So, if the suppose uh, there are different type of application for like for Visa, VST, for Mastercard, and chip. So if two different applications are embedded in the one card, then it is called as the two different product are there in the one card. We will discuss in detail about this in the subsequent lecture or in the same video in the subsequent slides. In the EMV, it gives the issuer more flexibility uh, to use uh, different crypto card card holder verification method. Like in case of Matchstep, there are various cryptography methods like PKI cryptography can be used. Similarly, ICC also support card holder verification method and can be used in different type of transaction for the authentication purpose. An EMV card can be used for different products. So for each product, we refer it as application, and each application correspond to different product of different scheme or say same scheme. Says Mastercard debit card or Maestro credit card or ruPAY credit card. These are all different applications since these are different products. Applications are identified by their unique AID. AID stands for application identifier. As you can see, Master credit card is having different AID, ruPAY credit card is having different AID. And AID consists of two components. First is RID. RID stands for Registered Application Provider Identifier. It is unique to scheme. So suppose Mastercard is having one unique RID, RuPay is having another unique RID, and Visa is having different RID. Next component is PIX. PIX stands for Proprietary Application Identifier Extension. So this is unique to a particular product within the scheme. So suppose uh, there is there are different kind of product within the RuPay. So suppose RuPay business card or RuPay gold card or RuPay platinum debit card. So these are different products within the RuPay scheme. So RuPay is having different RID and PIX proprietary application identifier is different for each of the product within the RuPay. So like here I had referred Mastercard RID is this, and within the Mastercard Maestro Pix is for example 1010. So total AID for that particular application will be these many times 04 and 1010. So this AID is made by RID and PIX. This AID can also be seen on the transaction receipt that are printed when you do any transaction at any merchant POS device. So here you can see in the one example I have taken in the HDFC receipt. If you can see, AID is shown. In the earlier slide, I had discussed about the format in which the data is stored in EMV chip is BER format. BER stands for Basic Encoding Rule, and TLV stands for Tag Length and Value. So tag is 1 to 4 byte long integer, length is 1 to 4 byte integer representing a value or branch size. We will discuss about this TLV format, how the data is stored, what data is stored in the subsequent slide. So in the EMV chip, data is stored in like tree-like format. So you can refer it as like a master folder is having different folder, and then at the end, each folder is having some unique files. Some files are contained within that folder. So first is master file. Master file consists of ADF file, ADF application definition file. These are unique to a particular application. So suppose you are having a EMV card which is having RuPay and uh, say Discover. Both the type of application are embedded in your EMV chip. Then the Mastercard is the main folder which your EMV chip consists, and each and Mastercard these master file with will have two different ADF file. ADF is for a unique AID. Like for each application, there is a file that is called as application definition file. Then file are having record we call it as AEF, and then each record is having multiple data objects. So data object is the smallest element that is consists in your EMV chip. The smallest piece of information that is stored in your EMB chip is called as data element or data object. For example, PAN number or cardholder name, it is a data element or data object. So each data element has a unique tag and which is provided by EMVCO. You can check what are the different tag available for different data elements. Every data element that is stored in tag length value format is called as data object. For example, if you want to store this 16-digit PAN number, then the tag for this PAN is 5A. So for PAN data element, tag provided is 5A. Length of this PAN number is 16. It will require 8 byte if you store it in BCD format. Then the data object can be written as first tag 5A, which is 5A. Length is 8 bytes, so 08, and then we can store the PAN number. So all the data object is stored in the TLV format in your EMB chip. Multiple data element or data object together forms a record. So record can also be referred as AEF, application elementary file. As you can see in the image, multiple data objects in the form of TLB are stored together to form a record. So in the image you can see four objects in the form of TLB together form a AEF, that is application elementary file. Multiple AEF forms a ADF. ADF stands for application definition file, or we can say that a particular application. So uh, each within the ADF, each AEF has a unique sort file identifier with which ADF is addressed. So if you want to address an application, uh, you will identify it by using AID, that is application identifier. And within the application, if you want to identify any record, you have to refer as AEF. AEF, that is application elementary file. So ADF is nothing but it is a file that is unique to a particular application or identified by using the AID. Now let's look about the directory definition file DDF. So it is you can say that it is an array of pointer. If your EMB card is having multiple application, then to identify each application you will require some indexing kind of thing. So for that we refer the file known as directory definition file. So for EMB standard, this file is referred as 1pay.sys.ddf01. So there are different data elements that are stored in EMB chip. Like your application data is stored AID, issuer country code, default country code, etc. Data related to cardholder like cardholder name, PAN, etc. is stored in your EMB chip. For card authentication, application data, signed static methods, there are various methods SDA, DDA for authentication of card that are stored as a form of data element in EMB chip. We will discuss about SDA, DDA in later in next videos. Regarding cardholder authentication, EMB chip is also having the capability to do the transaction offline. So PIN is also stored in the card in the encrypted form. Then other miscellaneous data is also stored as data element like pin invalid pin try counter and various other things like PDOL, application transaction counter, ATC, and other things are stored in the form of data element in the EMV chip. And we will discuss about these elements in the subsequent lectures. So thank you so much. See you in the next segment of the video series.